Hello everyone, welcome to CIS101, and this is Bob Hendry. Today is Tuesday, October 2nd, 2018, so welcome to class everyone. Tonight we're going to learn about casting, like a fishing pole, like you cast with a fishing pole. But in computer science, casting refers to making one data type out of the next, or taking a string and putting it into a number, or a number and putting it into a string, and also like making strings in the dates. Now casting is an important concept in computer science, and we're going to go over the basics of it tonight. Specifically, we're going to be using Oracle and PL SQL to demonstrate casting and how numbers can become strings, and perhaps strings numbers, and then strings in the dates. So sit back and enjoy and watch this lecture on casting. Well, let's get started. Now remember the objective of this lesson. What we're going to do is we're going to show you how Oracle casts different data types. Now when we talk about casting, we really talk about going from one data type to another. Now as we talked about previously, Oracle and most database management systems support three different fundamental data types. They support dates, they support numbers, and they support strings, or in Oracle, we call them varchar or varchar, depending on what your dialect is. So for the remainder of this lesson, we are going to go over a hands-on exercise, and I'm going to demonstrate to you how Oracle handles these different data types. Again, the different data types being numbers, strings, or varchar2, or varchar, depending on your dialect, and dates. So let me sign in. Now I'm going to sign in to my Oracle Apex account, and we're going to build a simple table, and then within that simple table we're going to build, say, about 3 or 4 different columns, and I'm going to show you how these different columns react to different data types. So if you want to, you can use an existing table that you already have, but in this case I'm going to use a new one. So let me build a script that's going to build a table for me. So let me go into SQL Workshop, and I will build a new SQL script that will build a brand new table for us. And again, this is just a table that we're going to be using to test our different casting functions on, or our different casting mechanisms on. So let me go and create a new script. So let me scroll over and create a new script. And I'm going to call this guy SC, and I'll say create. And we're going to call this one Cubs. So quite simply, I'm going to say drop table Cubs. And let me recreate the table. Create table Cubs. And I'm going to give this table the 3 different fundamental data types that I just mentioned. So we will say, how about player number, if I can spell it right. And the player number will be a number, comma, player name, and this will be varchar 2, and we'll say it could be 20. We'll make it intentionally short. The name you would think would be larger, but for our cases, we're just going to make them pretty small. So if the player number, the player name, how about the salary? And that's a number. And let's see. We got the player number, the player name, the salary, and we will say signed date. This is the date the player signed with our team, and we'll call this guy a date. Okay, and let me save my script by clicking on create, and my script's created. And I don't think I have any problems in there, but let me go back in there and take a look. Okay, so that's what I have here. I have drop table Cubs, create table Cubs. So we have 4 different columns. We have the player number, the player name, the salary, and the sign date. Now, what the objective of this lesson is I'm going to show you how Oracle handles data types, or can convert one data type to the next. And when it does that, it's called casting. C-A-S-T-I-N-G, casting, like a cast on your hand or your arm if you break it. Now, casting refers to the ability to morph data types into other ones. For example, strings into numbers, numbers into strings, stringers, like I'm fishing, strings into dates, and vice versa. So anytime you're converting or you need to convert one data type into the next, we say we are casting it. Now, casting is an important concept in your IT development. It goes well beyond what you're doing here if you're just beginning working with IT systems, either databases or languages. If you're working with languages such as Java, C#, or any other ones, or C++, you're going to have to deal with casting, or VB.NET, any of them. Because in languages, including database scripts like you're writing here, or scripting languages, you're almost always going to have to deal with going from one data type to the next. You think it's intuitive, but there's a lot of steps going on in there. We have what's called implicit casting, I-M-P-L-I-C-I-T, implicit, which means that the database or the language will automatically make that conversion for you from a number to a string to a date to whatever. The permutations are really many there. And we also have what's called explicit casting, C-I-T, explicit. So there's implicit casting, which is the language does it for you, and there's explicit casting, which means that you have to explicitly say this is the data type that I want to make that conversion. Now, different database management systems, and indeed different languages, are different. Like, for example, Java is an explicit casted language, which means if you're trying to put in a string into a number, you have to say via functions, I want to make this into this kind of number. So you have to pass that string to a number. Also, C# is explicitly cast, which means, again, just like Java. Now, languages like Visual Basic.NET, VB.NET, are implicitly cast, which means that the language or the database management system will attempt to make that conversion for you. And if it can, it just does it. It doesn't fail. It doesn't say, do you really want to do this? It just does the conversion for you. So while we're going through this exercise, I'm going to be going through examples of explicit casting. I'm going to show you how Oracle is an implicitly casted language. So we're not going to do much with explicitly casting in this lesson. We're just going to work with implicit casting. So anyway, let's get back to the example. So in this example, I got a Cubs table, and again, I have a player number, which is going to be an integer. You know, your player number is going to be a 1 through 99. There's not going to be a decimal in there. Player name, which I kept short on purpose, and for the player name, you know, we're going to have up to 20 characters. That's a little short. You're going to see why. We also have the salary. The salary is called a real number. Now, there's two different types of numbers. We have integral numbers, which is, again, player number. I mean, you don't go up on the field and there's player 17 and a half or 17.3 or 17.9. It's 17. So when we have a whole number that we deal with, it's called an integral number. We don't deal with decimals. We don't deal with fractions. Certainly, we don't deal with floating points or decimal points, which would be, again, a fraction. We also have salary. Now, salary is going to be a real number because salary probably will have decimals on it. Now, if you make $1 million a year, you probably don't care if you make $1,000,005 a year. But that is a different type of number. When we have anything with a decimal point in it or a fraction, it's basically the same thing. So let's just say you make $10 an hour. That would be an integer. You make $10 an hour. If you made $10.25 an hour, that would be called a real number. So we have two different types of numbers. We have integrals and reals. So if you earn $10.25, that's basically a fraction too. That's like saying you're making so much money plus 1/4 of the next. So when you think of in scripting or in database languages or anything about dealing with numbers in languages, such as here a database script, which is a language, the language is PL SQL, anytime that you have a decimal, you have a fraction too. Like a penny is 1/100th of the next dollar. 50 cents is 1/2 of the next dollar. 99 cents is 99% of the next dollar. So decimals and fractions are really the same thing. I'm kind of beating this in the ground a little bit. All right. Now, in addition to those two different numbers, there's also a bunch of different other data types that we can say. For example, a floating point number is longer than a double floating point is larger than a floating point. Now, we're in the beginning stages of this, so I'm not going to go into all the different data types and what's supported in them, because I want you just to get comfortable with this script and comfortable with, implicit casting versus explicit casting. And then at some later date, we could go into all the different types of numbers that can be there. But there are different types of numbers. As a matter of fact, in the code review, this probably wouldn't pass. Your peers would look at this and say, well, what kind of number is it? Is it an integer? Is it a long? Is it a floating point? Is it a double floating point? What kind of number is it? But from here, just know that we have numbers. Now, in Oracle, since we're dealing with Oracle here, Oracle is very, 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 very forgiving on what we put into it. Oracle will really bend over backwards and try to deal with whatever you give it and handle it without you really giving it any undue interference. What does that mean? That means that if you pass into it for the number 17, it will accept it because 17 is a number. If you passed in 17.5, Oracle will take it because 17.5 is a number, even though in reality it's a different kind of number, because 17 is a real number, 17 is an integral number, and 17.5 is a real number. But Oracle will say, you know what, if you say it's a number, I'm just going to try to make it a number if I can. So 17.5 would be a number, so Oracle will take it. Now, if you think about that, there's ramifications of it. If you talk about constraints of the table, we probably don't want 17.5 to be a valid value for the number. So in that case, we're not going to do it here. Like I talked about in the peer review, we would look at this and say, well, what kind of number is it? We shouldn't allow a real number here. So we should allow just an integer rather than a real number. But we'll talk about that casting, and we'll talk about that in a second because we're talking about casting here. Now, ditto with salary. And if I put in $1 million, 10000, I guess if we made $1 million, I wouldn't be making this video and you wouldn't be listening to it. But if we made $1 million, Oracle would look at that and say, yeah, $1 million is a salary, so we're just going to put it in. Give me 1 second here, folks. Make sure we're still going there. Good. I got an ominous message that popped up on my screen. Make sure that we're still good here. So if we made $1 million and we try to put $1 million into the salary column, Oracle would take it. And it would say $1 million is a number. We're going to take it as a number. But $1 million, and I'll give you an imaginary extra credit bonus point to get this right, is $1 million an integer or an integral number, or is it a real number? Well, $1 million without a decimal would be an integral or an integer because we're not putting in any decimals. It wouldn't be real. But we're a real number. Like there's such thing as unreal numbers, but there actually is. There's a series of numbers called imaginary numbers, and if we have some time later this semester, we'll have a lecture just on imaginary numbers because it's a fascinating lecture for me at least. So anyway, so we got that. So dates act a little bit differently as far as casting goes. Now, as far as casting goes, Oracle deals with default date ranges or default date formats. So we can only put in so many different ones if we want to put it in as a string. Otherwise, we have to use a toDate function or a toChar function. We'll just work with the toDate function, and we're going to be doing some surfing and making a couple errors as we go. Remember, this is a live class, even though that you're getting the video of it, so it's not really a canned video. Everything's being doing live. There's not any editing done behind the scenes for you. So anyway, so we got this script. So let's run it. We run the script, click run now, like I want to run it later, right? Of course I want to run it now. This drives me crazy. So we should get this. Table review does not exist because when we try to drop the Cubs table, it's not there, and then it says the table's created. So what I'll do now is I'll go to Edit Script, and I'll let you guys take a screenshot at this, because we're going to go into SQL commands now, and we're going to get back to this a little later. A couple things about this. I'm filling in some dead air. Do we have to recreate the table every time we use it? No, we don't. But for the purposes of demonstration and education, we're dropping it and we're recreating it just so we know there's no, the technical term is crap. There's no crap in there. So we're just dropping it and recreating it. Now remember a couple things here. Now this is from looking at some of your exercises here. Remember when you are dealing with this, every single semicolon that you see here is a command. So how many commands do we have here? Well, we have two. We have drop table cubs, and we have the create table. So we got the drop and we got the create. Now remember, again, we use white space just for visual presentation. Again, the technical term is making it look pretty, where we can at least look at a nice left alignment here and we can see what we're doing. Also remember that we have commas after each column name, but we don't have one after the last one. So if you add something to the end, you'd have to put a comma there after date and then add your column. But we're not going to do that. Don't do that. Why would you want to do that? Okay. So anyway, so we got this. Drop table cubs, create table cubs, all this other good stuff. Make sure, we run it again just to make sure it's there. If you click run once and it works, click it twice to make it work again, right? There we go, table created. Good, 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 good. Okay, so let me take a picture of this. So we got the player number. I'm writing this down. Number, we got the player name. We got the salary. We got the signed date. There we go. All right, so let's get out of here and go into SQL commands. So let me go up, SQL scripts. Let me go up one step until we got SQL commands. Now notice something about our table before I get into writing some commands against it. Think about what we put as far as constraints in there. Now, on purpose, I didn't put any constraints because I don't want us to fall, into ourselves here. I'm protecting us from ourselves here. So what we're doing here is we're going to be working without a table or with a table without any constraints. On purpose, I didn't put a primary key. I didn't put a check constraint. There's no foreign keys. There's no not nulls. None of that. None of that foolishness. What we're going to do is we're just going to focus on casting and how Oracle works with data types. And while we're doing that, we're going to have a lesson on implicit casting versus explicit casting and all the other good stuff. So how about this? Let me type in import into, and we're going to put in the cubs. Values. It doesn't have to be all in caps. As a matter of fact, well, SQL actually probably should be. And first, let's do something that won't break it. We'll put in the player number is number 17. He is Bob. And Bob makes $1 million a year. Probably not a lot for a baseball player, right? And his sign date is 01/17/2018. And I'll kind of hover it there for a second. Now, one thing about these remote classes is one of the advantages is you can always stop the video and see exactly what I'm doing here. So again, remember for this semester, we're going to have a mix of live classes and remote ones, although most of them will be live. Most will be live. All right, anyway, so let's look at their syntax. Import into, whoops, into, supply the name of the table, and then you put in the values. And the values are denoted starting by an open paren and a closed paren. Now we have 17, Bob. He makes $1 million a year, and this is the day he was signed. So let's take a look at what happens here. Now, again, we're going to keep constraints out of the conversation, not just for now, but for the remainder of this lesson, because I'm trying to eliminate all of that and just get down the data typing. Now, when I try to run this import, oh, pardon me, it's my fault. It's insert. I hope you didn't hit enter, right? Because if I get a phone call or a text message saying, Bob, I ran your import statement and it didn't work, it's because I meant insert rather than import. You think I would know that by now. Again, it's a walking and chewing gum at the same thing, I suppose. All right, anyway, so as soon as I try to run the SQL statement, what Oracle will do is it will look, and again, we're getting constraints completely out of the conversation. What Oracle will do is it will look at each of the value and it'll match them. First, it'll count them. It'll say, okay, insert into Cubs. Do I have a Cubs table? Yes, I do. How many columns does that Cubs table have? It has 1, 2, 3, 4. And again, it doesn't count my values, but what it does is it does count. It does go to the Cubs table, and it does count how many columns I have in there. And it says, do I have as many values being passed into the Cubs table than columns that exist there? So if the Cubs table has 1, 2, 3, 4 values in it, am I attempting to put 4 values into that table? The answer, yes, I am. So we passed that gate. So now what Oracle says is, do the data types match? So it goes to the Oracle, looks at the table and say, okay, what are the data types for those 4 columns? And Oracle comes back, or the section of Oracle that looks at that comes back and says, the first one is a number, the second one is a varchar, the third one is a number, the fourth one is a date. So then Oracle says, good, good, good. Do I have the corresponding data types that are being passed into that table via the insert statement? Okay, so then we look at it and say, okay, we're putting in, or the insert statement is putting in 17, it's putting in Bob, a string, it's putting in, or attempting to insert 100,000 as a number, and it's attempting to put in 01/17/2018 as a date. Now this is an anomaly, because if you take a look at this, it's not necessarily a date. More on that in a second. Let's get something to work, and then we'll work our way out of this. So let me click on Run. And I should get one row inserted. Now I'm not going to prove to you that this worked. You know, we could go in and write a select and get this data out, but it's going to look predictable. It worked, and we don't need to go in there and prove that it's actually working, because it is. So anyway, at this point, we do a couple of things. Well, number one, it works, but let's talk about data typing. This one was easy, was happy path, and I said kind of ignore this for a second. Let's try something else. Let's say I'm going to put in 17.5 for the player number. The player number is 17.5, and I'm going to put in, and the player name is Cadence. Now Cadence makes $9 million a year and 25 cents. We're going to work with dates at the very last, because some of you are looking, raising your hands, saying, well, what about this date? It's not exactly a date, it's a string. And you're right, but we'll handle this in a second. So we got this. We're going to try to put in Cadence. Now remember, we have no primary keys, foreign keys, check constraints, none of that. We're dealing with a single table with 0 constraints on it. So when I take this example and I run it, I get 1 row inserted. Again, big deal. But a couple things here. And this has to do with data types and stuff. So I'm going to leave a couple of things open here. But I want you to take a look at some of the things that work that probably shouldn't have. cadence is number 17.5. Now, I don't care what sport you're into. You might not be in any sport, but 17.5 is the number of the player, right? Is this possible? Well, generally, right, in real life, this probably wouldn't be valid. Because, if you look at the back of a player's number, the back of a jersey, soccer, baseball, football, Indy 500, NASCAR, any of those things, you're not going to have a decimal for a number on it. So keep this in mind. I'm going to leave this open-ended here, that when you're working with numbers in any language, Oracle, Java, C#, SQL Server, really at some point you have to really be cognitive on what kind of number you're looking for. Because right here you can look at this and say, well, it's not really number 17, it's 17.5, it's number 17. So there's other options for you to actually use here. You could make this a string if you want, because you could make the argument, if you wanted to, that we're doing no arithmetic or sorting on the jersey. Actually, we are doing sorting on it, so it could be a number. I'm waffling back and forth because sometimes when you choose a data type, sometimes it is a judgment call. I mean, sometimes it could be a string, it could be a number, it depends on how you use it. A good example of that is like your social security number or your driver's license number without the hyphen in it. Let's just say you want to enter your social security number. Mine's 32412122345. That's not it, of course. But you can make the argument that since we're not doing any math with that, it's not necessarily a number. We can treat it as a string. A little more on that later. But anyway, talking about casting again. Remember, our lesson here is casting. And we talked about different types of numbers. In this case, 17.5 is a number. Cadence is a string. $9,000,025 is a number. And we got this date thing. And again, dates are anomalies, so we're going to handle that at the very, very end. But that worked. Let's try something else. Let's just say we're going to say jersey number 20. Notice I got it in single quotes, not double quotes. Then I'll say this is Cassie. And she makes $7 million a year with no change. Do that again. She makes $7 million. And we'll just keep her the same date as well. Insert in the Cubs values 20 Cassie, 70,000. I'll put 70,000 in quotes too. Now notice we're changing data types. We're saying 20 is a string. Cassie is still a string. She makes $70,000 or $700,000. Is that right? Let's make her. Let's see. It doesn't matter what it is as long as we cite it correctly. She's making $700,000 a year. She must just be starting. Wouldn't it be nice that for like a minimum wage? And she started again on the 17th of January, 2018. So we run this, and this works too. Now this goes against what I just told you, that when we're doing the insert statement, Oracle looks for, number one, does the Cubs table exist? Yes. How many values does the Cubs table have in it? And Oracle says it has 1, 2, 3, 4 of them. So then Oracle says, well, how many values are we attempting to put into the Cubs table? And then it responds 1, 2, 3, 4 of them. So we're doing good so far. We're putting in the same number of values into the same number of columns in the table Cubs. The last thing Oracle looks at is, did the data types match? Now this is where this becomes important. So if you fell asleep until now, which most of you have, it's time to wake up, and this is where the most important part is. Notice the data types don't match. In the table, the player num is a number, the player name is a variable character, the salary is a number, and we'll forget about dates for the last part. So just take it on faith. But it worked. Why did it work? Everything I told you said that it shouldn't work because the data types aren't the same. Now this is where casting comes in. C-A-S-T-I-N-G, casting. Like if you're fishing, you have a fishing pole, you're casting with your fishing pole. What Oracle is doing is it is making one data type into another one. It's looking at this and saying, okay, first of all, I got a string, and the string is 20, 20. That is my string. And I'm trying to put this into the table, and the table has the column data type. We're not going to talk about the column name. It doesn't matter. But for the most part, it doesn't. So here, what happens is Oracle says, I'm trying to put the string 20 into the number 20. Now, believe it or not, if you're a Java programmer or a C# or C++ programmer, that's a big deal. That would fail. In your code, if you said I want to put a string into a number, it just would fail. It'll say the data types don't match. But Oracle is implicitly cast, implicit, which means it will make that data type conversion if it can possibly do so. Now again, for you beginners, you're rolling your eyes. You're like, well, what's the big deal? Why can't it just make the string 20 into the number 20? And the answer is, if you're working in computer science and IT, that is a big deal because you have a data type mismatch. The compiler would say, don't do this. Don't do this. Why do you want to do this? Why are you taking a string and putting it into a number? There's got to be a problem there. So what you should do is you should explicitly cast it. Say, okay, I want to make this string into a number. But that's not what Oracle does. Oracle looks at this and says, I will try to cast this. Try means implicit. So Oracle looks at this 20 and says, can I make this 20 into a number? And it can't. So Oracle says this one's okay. And then it goes to this one here, or this second value that we're passing in, and said, all right, we have Cassie. Is Cassie a string? Okay, Cassie's a string. No further action is required. Cassie's good. And then Oracle will say, what is the value of the third parameter passed into the insert statement? And the answer is, well, it's 700,000. And then Oracle says, is it a string or a number? Well, it's a string. Okay, problem again. We're trying to put a string into a number. But Oracle, again, will try to implicitly cast this. Implicitly means it'll try to make the string into a number. So it looks at it and does some further thinking. And it says, Oracle says, can I make 700,000? Can I make 700,000 into a number? And the answer is yes. So it does so, and it just makes it work. More on this dates in a second. So Oracle will look at this, and it will work. Now, some of you will look at this and say it shouldn't work. It should automatically bomb. But Oracle, like I said, like a lot of other languages, and what comes to mind is like visualbasic.net, will actually try to do the conversion, and if it can, it'll do it for you. So this will work. So I'll click on Run, and it will actually work before. And it worked again, and don't worry about this 20 being entered twice, because again, it's not a primary key. But let's try a couple other things. How about we say Cassie is number 25, and she makes, how about $70,000 a year? And I'll do this two ways. I'll make 75. I'm doing too much at once here. Let's do the following. Let's have number 21, and this is going to be Kathy. We'll work with T's, with C's. And Kathy makes 700,000. Let's make her make 1,700,000 a year. Again, don't worry about dates. We're doing dates at the very end. Take a look at this. When I click on Run, will this SQL statement fail, or will it succeed? Remember, when the SQL statement fails, no data gets put in, and we get an error message. Ooh, and let me get rid of this guy here. Kathy is 21, number 21, jersey number 21. Her name is Kathy, and she makes $1,700,000 a year. This will fail, and let me show you why. When we use numbers, we can't use any kinds of currency symbols. Now you're looking at this, and you're looking at the comma, and you're like, well, that's not a currency symbol. That separates my hundreds from my thousands. And then you look at this and say, well, that's not a currency symbol either, because it separates my hundreds of thousands by my millions. If you say that, you're speaking at this in a truly American point of view, because it's a currency symbol for the United States. So we look at this and we're like, well, it shouldn't count, but it does. So if I click on run, Oracle says too many values, specifically because I got this comma in here. But let's just say I don't. Let's just say that we have 1,700,000, and I'll get rid of those commas, and we'll put, and give me a second, 30. Look at my timing here. Making sure my timing's still right. Okay, so if I try to run this, I'm going to fail. Oracle is looking at this entire value, and it's got a $sign, 170000, whatever it has on there. It's got that sign on there, and it tries to make that into a number. It tries to cast it. It tries to cast $sign 1,700,000 into a number. And guess what? It can't. It can't cast this because it doesn't know what this $sign is. Now again, you're looking at this from a truly American point of view, and you know what this is, but Oracle doesn't. Oracle just looks at numbers. There's no such thing as a currency data type in Oracle. Now, if you're working with SQL Server or Access and some other database management systems, you will have currency. You will have currency as a data type, and you get to specify what kind of currency you're using. But in this case, you don't. You just have basically your number to work with. So let me get this back out there again. It will not cast that. It doesn't know what it is. All right. So anyway, I click on run, and this should work fine. So let me click on run to show you that it'll work okay. So anyway, and strings are easy because they have to have the single quote around them. You can't have a double quote. If you have this and this, it's not going to work. Remember, you only deal with single quotes when you're writing SQL statements. To show you that this won't run. And you get column not allowed here. When you're using double quote statements, it specifies that you're referring to a column. You might not know what that means, and if you don't, that's fine. For the purposes of this video, you don't need to know that. It's just saying it refers to a different column. All right, so anyway, we have casting. Let's do some other stuff with this. Let's just say we have a real long name. Say Kathy, and we'll put in Von. So let's put a really long name for Kathy. Kathy Von Frankenstein Von Bob. Kathy Von Frankenstein Von Bob. And we try to run this, and we get a value is too large for column. Now this is to be expected. Now if you remember when we created the column for the name, what we did is we created it to be 20 characters long. Now Oracle is still trying to cast this. All rules apply, but what it's trying to do is it's trying to cast a value that's 30 characters into a value that's 20 characters. Now Oracle can't do that. It's saying, why do you want to do this? It's not going to work. So casting works within, or pardon me, casting does take effect within different data types, as it does within the same data type as it is here. So we're going to change Kathy to something a little bit more manageable, and change 22 to 23 just to keep it unique. We don't need to. Again, we're just showing you casting. And I click on run, and it should run as advertised. All right, so we've seen casting with dates and numbers. Pardon me, not with dates, but we've seen casting with numbers, where we take 23 and, like for example, if we make this a quote, Oracle can make 23 and make it a number. But we also saw that we shouldn't necessarily have to expect our language, in this case Oracle, to do the cast for us. remember when we did something like this, when we said 23.5, and we actually ran the SQL statement. When we ran the SQL statement, Oracle allowed us to take that 23.5, and it said, I can make a number out of this. And it took that number and it put it in the database. Now, what I was trying to explain earlier is casting isn't necessarily a good thing. For you Java programmers and you C# programmers, you know what I'm talking about, where you can't really take a string 25 or 23.5 and expect the language or the compiler to put it into a numeric data type. You know, if you try to do this in C or Java, you get an error message. It's because those languages are explicitly cast, which means that we have to say, all right, we know this is a 23.5, and we know it's a string, but we want you to make a number out of it. Here, Oracle, like I said, will not give us an error. Oracle will implicitly cast 23.5, and it'll say, all right, you want me to take a string, and the string's value is 23.5, and you want me to put this into the database. Okay, or the table. I can do that, and it does not fail. Now, in a code review, you know, you would look at this and say, I told you so, because 23.5 is really not a valid number, even though you would let Oracle do the casting. So there's going to come a point, and it's not going to be today, but there's going to become a point where you're going to have to use or put some thought into what kind of numbers you're using. And even in this case, maybe not in this case, but in some cases, what kind of strings are you using? In numbers here, it's kind of obvious where we don't want 23.5 to be valid because 23.5 isn't valid, even though Oracle can make a number out of it. So keep in mind that in your travels, and it's beyond the scope of this class because the scope of this class is just explaining casting as a concept, you're going to have to pay some close attention into exactly what kind of variables that you're using and their data types. So anyway, again, this video is just really just for the basics for casting, so we kind of already got that. All right, so we did casting, the basics, strings into numbers, a little bit, strings into numbers, a little bit, and numbers into strings. And we talked about, you know, valid kinds of numbers, integral data types versus real, and all that other good stuff. Now let's talk about dates a little bit. Let me give you a little bit of dead air to kind of take a screenshot of this if you like. Okay, so let's talk about dates a little bit. Now, when we ran this, when we run the SQL statement, this works. This string casts directly into a date. Now, why does it? You look at this and you're just like, well, this is not a date data type. If you look at the table and you look at the Cubs table, this data type is defined as type date. But, we're passing in a string. Now, Oracle is looking at our string, in this case, 1/17/2008, and it's making a date out of this. Now, how does that work? Oracle works with what's called default date formats, which means if you use specific date formats as a string, Oracle is able to recognize that date format and then make it into a date data type. Now, as it just so happens, this is one of them. But let's try some different things. How about if we tried like January 17th, 2018, and we tried running this. And again, don't worry about any primary keys or anything. We're just worrying about date and default date formats. So give this a run, and it actually works. So this is a default date format. How about this? Let me do Jan, 10th, 2018. So let me click run here. And it works as well. So this is the default date format. Let me try another one. Let me try 1899 01 10. Let me try this one. Let me give it a run. And I get this message here, not a valid month. Let me explain to you exactly what this means. Now, you're looking at this and you're just like, well, what do you mean not a valid month? Oracle is looking at this, and Oracle doesn't know what to do with it. You're giving it 1899-0110, not a valid month. Basically, Oracle doesn't know what to do with this. It doesn't know if the month is wrong, if the year is wrong, or if the day of the month is wrong, or the month of the year is wrong, because it doesn't recognize this as the default date format. What's happening is Oracle is running the SQL statement. It is looking at the database or the table, and it's saying, all right, we have a table and the data type is date. So is this a date? Oracle looks at this and says, I don't know if it's a date or not, but it doesn't know what's invalid or which of these is invalid. Is it an invalid month? Is it an invalid date, or is it an invalid year? It really doesn't know. So it just thinks the month is invalid, so it kind of spouts this message out. So it's up to us to determine exactly how to fix this. So let me show you some casting functions. And I'm not going to go too far down the rabbit hole on this one, because casting functions is really beyond the scope of this video, and it's really probably a series of videos in its own right. Just know that casting is a big deal, and sometimes you have to explicitly cast this stuff for Oracle. So let me go and open up another web page, and let's look up a function called toDate. What toDate does, and you're going to see it in a second, is it's a casting function that casts strings into dates. So I'm going to type in Oracle toDate example formats list. Now, don't worry about a specific database that you're going to, or a specific website. You know, you could just get these default ones anywhere. Like, for example, I like the Stanford documentation, but again, you can find this anywhere. But this is what you're looking for. What you're looking for is you're looking for the toDate and the date formats. Like here we got our date formats. So we got toDate, which is right here, and then we have the string and the format. The string is the string representation of the date, which we already have. If you go back to SQL commands, this is the string representation of the date that we have. So I can say toDate and then put in the format. And it is a 4-byte year. So it would be 4-digit year. I'll just type that in. 1, 2, 3, 4 hyphen a abbreviated month name, numeric month, hyphen, and then for the day, it's the day of the month. So we get day of the month, which is DD. Whoops, a little bit too much there. Just DD. Little copy paste action. And that's our toDate function. And then we need our last quote, or our last parentheses to close out our format. So what we're doing here is we're using our own casting function. That's what we're doing here. We're saying, you know what? You don't know what 1999-0110 is, but this is what it is. It's a 4-byte year. It's a 2-byte month of the year, and it's a 2-byte day. So let me run this, and we should run successfully. And if not, we'll fix it. 1 row inserted. So this works. Now, why did I show you the toDate? Well, I wanted to show you a casting function. Now, casting functions exist for every data type, for dates, for numbers, and for strings, and you may have to use them. Now, again, this is an intro video for someone that's got between 0 and 6 months experience working with either databases or scripting or working, in the field of computer science or information technology. So there's a lot that we didn't go through. This is just an introduction to casting and how you may have to cast from one data type to a next, or how the application, in this case Oracle, actually does a lot of this casting for us. So we went over, in this case, numeric casting, and also we went over date casting. We didn't do much with casting with alphanumeric characters, but we probably should. How about we do this? Let's do a cast with this string here. Let's just say we have Kathy Hendry von Hindenburg. Hinden Hindenburg. B-U-R-G. Kathy Hendry von Hindenburg. So I try to run this, and I get an error message. So Oracle cannot cast this from from 27 to 20. So what I can do is I could put in a casting function. I could say, you know what, only give me the first 20 characters of this, and I'll lead you down the happy path. The string function that we use is called trim. So how about we do this? We go Oracle, we'll say trim function. Now what trim does is it allows us to take X amount of characters and ignore the rest. And again, I don't really like the Oracle documentation website. It's kind of hard to read, but you could look for this anywhere. And in a second, I'm going to show you how you can find like all of these. So what trim does is it'll get any leading or trailing spaces, but there's probably a better one to use. Look to the right hand side here. These are all the Oracle string functions. Now again, don't get really uptight about exactly which website I'm at right now or web page, because you could look these up. These are the Oracle string functions. Let's look up left. I think left would be a good one. How about, let me see this, kind of scroll down. Substring would be good. Concatenate. How about ltrim? See, ltrim will return a string with all the characters contained in the set that are removed from the left end of the string. Let's look at this. I'm kind of leading you through these because I want us to try to determine exactly which one we should use. Now, ltrim will, in this case, we'll just remove these spaces. Let's look at substring. Again, these are all casting functions. I like this. This is better. Substring gives us a substring of the string that we're using. How about this? This is a good one. What this will do is substring is a casting function we could use for our string that will only give us X amount of characters. Like in this case, substring will give us, starting from the first, and it'll give us 6 characters to the right of the first. So we could use a substring function to only give us a 20. So we can put in substr substring Kathy van Hindenburg starting at position 1 and going to position 20. And I'll leave that up on the screen for you. And again, I fully expect you guys for all this remote stuff to be stopping and starting and stopping and starting the video. I mean, that's why, as far as the lecture goes, it's about an hour as far as lecture time. But if you're stopping and starting like we would in class, it's probably double that. So this is kind of condensed. So this is a substring. It'll look at this value. It'll start at position 1 and only give me 20 of them. And I'm going to invalid SQL statement. And let's see what's wrong with this. There we go. We didn't need to put the 1 in there. That was the problem. We didn't need to put the 1 in there. So we're just saying get the first 20 characters. We don't need to say start at the first. So this works just fine. So this will give us the first 20 characters, and it'll chop off the rest of them. So substring is again a string casting function that we can use to take, in this case, the first 20. Now, obviously, we're looking at this, it's a little bit longer than that. But remember, this could be a variable, too. I mean, sometimes we don't know exactly the contents of it. This is just to illustrate the point. So in this case, what we're doing is we're actually using our own substring function. Now, while we're at it, again, I showed you some Oracle string functions. I mean, you can also look up Oracle date functions. When I give you a lab assignment, I'm going to give you some links to look at. But again, don't get really uptight about which website I'm on. Just know that there's Oracle string functions, and you can kind of look them up. Like we can say Oracle, and we can say number functions or numeric functions. And actually, I like this website. W3 Schools is pretty good. It's a little light on stuff, but it's not a bad website at all about learning about this stuff. All right, well, I'm just about done. Let me wrap this up. All right, this is what we did today. This class was on casting. And we started simple, and we kind of ended simple. You know, we talked about casting and how it's the process of taking a data type and changing it into another one. Or basically making numbers in the strings, strings in the numbers, dates into strings, strings in the dates, and any other permutation or connotation on how that works. I also mentioned that casting is a big deal. It's something that you look at and you're just like, well, what's the big deal? Why can't it just, like in this case, make a 23.5 and make it into a number? Well, in this case, in an implicit environment, such as Oracle, it happens automatically, but it's not necessarily maybe what you want it to do. Like in this case, 23.5 is completely invalid because 23.5 is not really a valid Jersey number. So just because a language, or in this case, is implicitly cast, it doesn't mean it's a good thing. You Java programmers and C# programmers are probably sticking with this, saying this is why you don't implicitly cast anything, because just because you can make it into a specific data type, it doesn't mean you should, or it doesn't mean it's accurate. And you're certainly seeing it here. All right, folks. I hope you learned a little bit about casting. I hope these examples were useful to you. And if you have any questions, you know how to reach me. Of course, I'm a little behind on things. I'll catch up as soon as I can, and I'll get to you. Otherwise, thank you for your time. I'm finished with new material, and please enjoy the rest of your day. Thank you.